To factor a difference of two squares. Example 1. A squared minus 16. Step 1 is to figure out if this is a perfect square and if this one is a perfect square. That means you can multiply something by itself to get this and this. The square root of a squared is a. The square root of 16 is 4. If you don't know that, use a calculator. The difference of two squares factors out to two quantities. You have a and 4 in each one of them, but you alternate the signs, a minus 4. 4c squared minus 25. 4c squared is a perfect square because you can multiply 2c by itself to get 4c squared. In other words, find the square root of this and the square root of this, combine them together. C is the square root of c squared because c times c is c squared. And the square root of 25 is 5. So we'll have 2c and 5 in each quantity, but you must have a plus in one and a minus in another one. Nine is a perfect square, and so is a squared, and so is 36. The square root of 9a squared is 3a, and the square root of 36 is 6. So you could have 3a plus 6, 3a minus 6, or you could have factored out a 9 and be left with a squared minus 4, and then 9 times the quantity a plus 2 times the quantity a minus 2. Either one of these would be right. On this problem, let's try to factor out something. Or we can just leave it the way it is. Let's leave it the way it is right now and find the square root of 16x squared to be 4x and the square root of 100 to be 10. And if you do that, you must alternate signs. This is a right answer. But what if you factored out a 4? You're left with 4x squared minus 25. You also have a difference of two squares there. So you could have had 4 times the quantity 2x plus 5 and 2x minus 5. Either one would be right. On this problem, 4a squared and minus 64, that is a difference of two squares. So like we had in the last practice problem, you could go ahead and find the square root of 4a squared to be 2a and the square root of 64 to be 8. So you'd have 2a plus 8 and 2a minus 8. Or you could notice that you could factor out a 4 from each of those. So you could do this. 4 times the quantity a squared minus 16. Just divide a 4 out of this one and this one. So if you do that, you have a difference of two squares there, so that would be a plus 4 and then a minus 4. When you have an answer that has 3 items in it, 1, 2, 3, make sure you write all 3 items. Don't just write these two, because it will be wrong without that 4 in front if you go that direction. There we go. Alright, on this one, you don't have a perfect square here or here. So you have no choice but to see if you can factor something out. Looks to me like you can take out a 5 and what else? And x. So if that's the case, divide both terms by 5x and be left with x squared. And then you'll have 125x divided by 5x. That's 25. 125x divided by 5x. The x's cancel out. 125 over 5 is 25. Now leave the 5x where it's at and split up the difference of two squares here as x plus 5, x minus 5. On this problem, this is not a perfect square. 3 is not, and neither is 27. The a squared b squared is, so it looks like we have to divide out a 3 and be left with a squared b squared minus 9. 3 times 9 is 27. The square root of a squared b squared is simply ab. And the square root of 9 is 3. So you need an AB plus 3 and an AB minus 3. Alright, well clearly 8 is not a perfect square and neither is 98. A squared is. If we can get it by itself, then that will work. You do not have to divide automatically by the number that is out to the left because it may not go into this one. How about we try 2 and be left with 4a squared minus 49. If you do that, then you're left with 2a plus 7 and 2a minus 7 on the back end. You must have this with it as well.